graphing logarithmic functions. And so if you have your notes, go ahead and pull that out. So we talked about this a little bit on Monday. And so this is just kind of going to be a recap and, well, not a recap. It'll be a review of kind of the information that I gave you, and kind of pulling that all together. All right. So what I shared with on Monday is that logarithms are important because they actually can undo exponents. So when we're trying to solve an equation that has an exponent, like that has, 2 to the x power, and we want to figure out what is x, well, we have to have a way to get it down. So if we have, for example, 2 to the x power, and we want to solve for x, we don't really know how to do that yet. And that's where logarithmic functions come in, and they let us actually solve for x. So they do have some helpfulness. You can see on your paper there's a definition here. The logarithmic functions and exponential functions, they can go back and forth to each other. So if you have, this is how I was trying to say that we would remember this. You have a number that's your base, okay, and it's raised to an exponent, then that gives you an answer. So this is just a way to remember the relationship, an answer. So when you do a logarithm, you go to the basement to find the answer, and that results in your exponent. Okay? Or if you're a more mathematical person and you have b to the y power equals x, then another way that you can write that is y equals log based b of x. So the first thing we're going to do is we're going to rewrite logarithmic functions as exponential functions so you can kind of see the relationship. So number 1, we have log base 3 of 81 equals 4. Okay, so I know that 3 is the number that's in my basement, so that's my base. Okay, and the logarithm went to the basement to find the answer. So the answer is 81. And so then this is my exponent. So 3 to the 4th power equals 81 is a different way of writing log base 3 of 81 equals 4. These two expressions are basically the same. They're just different ways of writing the same thing. Okay, so if I had, for example, I don't have this on my paper, but let's see. Log base 2 of 8 equals 3. So another way I would write this is that my base is 2, and went to the basement to find the answer, which is 8. The answer is 8. And I use my exponent to do that. So 2 to the 3rd power equals 8. Okay, it's just kind of like a weird new way of rewriting exponents. So if I have example number 3, I have log base 7 of 7 equals 1. So I know my base is 7 because that's what went to my basement, 7, right? And I know my answer is 7, and my exponent is 1. And that makes sense, right? 7 to the 1st power equals 7. All right, so this kind of makes sense, Kyla? Sorta. Do some more examples. All right, cool. So number 3, we have log of 14, log base 14 of 1 equals 0. So if I rewrite it in exponential form, 14 is my base. Went to the basement to find the answer, which is raised to the exponent. So 14 to the 0 power looks like 14 degrees, but 14 to the 0 power is 1. That's how we would rewrite that. Okay. Okay. Number 4, we have log 1/2 of 32 equals -5. So this one looks a lot more complicated, but it's actually the same exact thing. So the base is going to be 1/2. That's what's in the basement. And that equals an answer of 32. And that means I'm raised to the -5th power. Okay. Give me 1 second. Let me grab my book because I don't love my notes right here. So let me grab my book so we can do a couple from the book. Give me 1 second. Okay, I'm back. So I'm opening up to 7-4. Okay. Wrong chapter still, wrong section, 7-4. All right, so that is rewrite the equation in exponential form. So I didn't do a very good job in my notes because, well, that is a big part of what you have to do. But number 9, so the homework is 3 through 27. Number 9 through 19, we need to do some work on those. Oh yeah, I need to update this to make this a little bit better. So, okay, so if you have your book, then grab it out, and if not, then I'm gonna write some on the screen. Okay, so basically 8 through 19 or 9 through 19 when you do your homework, it says to evaluate the logarithm without using a calculator. Now, this is not like I'll explain what I mean by this. So we have number 10, for example. Okay. Number 10, we have a logarithm that says the log base 6, that's a 6. I'm going to write that better. Base 6 of 216 equals what? So we'll say that's our y. Okay, we don't know what that is. So when I say evaluate, or when they say evaluate without using a calculator, what they want you to do is rewrite this in exponential form. So 6 is our base, right? It's our base. 6, the base goes to the basement to find the answer. So 216 is the answer, and it uses the exponent to find it. So we can rewrite log base 6 of 216 as 6 to what power equals 216? Okay. Now, this is where you might not know. I know that 6 squared is 36. I'm guessing 6 to the third power is 216, but I don't know that off the top of my head. So that's where I'm saying it's not like if you use a calculator to figure out what that is, that it's a bad thing. So, oops, put this here, calculator here. So if I do 6 to the third power, I get 216. So it's okay to use your calculator to guess, to figure out what is that exponent. So this means this has to be y equals 3. Okay, so 6 to the third powers equals 216. And so that means over here, right, I just said y equals 3. That means log base 6 of 216 is 6. No, is 3. Because I just said y is 3. So I've actually solved a logarithmic problem that I didn't think I'd know how to solve by changing it to an exponent. Okay. So for example, let's see. Excuse me. Number 11. I have log base 2 of 64. Okay. So, and that equals y. We're trying to figure that out, right? So if I rewrite this, 2 is my base. It went to the basement to find the answer, which is to some power. So 2 to what power equals 64? Again, you might not know this off the top of your head. 2 times 2 squared is 4. 2 cubed is 8. 2 to the fourth is 32, and I think 2 to the fifth power is 64. So let's just double check it on Desmos. I think 2 to the fifth power is 64. 2 to the fifth power is 64. So let's check. 2 to the fifth power. Nope, sixth power. 2 to the sixth power is 64. So I know that 2 to the sixth power equals 64, which means y equals 6. So over here, log base 2 of 64 equals 6. So that's how I'd solve it. Yeah. So that's how we would solve without using a calculator. I feel like I should do, does that make sense, Kyla? Or do you think another example would be helpful? Awesome. Okay. Actually, I'm going to do one more only because we didn't talk about I'm going to do number 15. Okay. Okay, so number 15 has a fraction in it. So what happens when we have a fraction? I want to give an example like that. So log base 16 of 1/4 equals some y. Okay, so I'm going to rewrite this. The base is 16. The log goes to the basement to find the answer. And it's just some y value. So what happens when your answer is a fraction is the question. What happens when your answer is a fraction? Well, that means that this exponent is probably going to be negative. Not -1, but it's going to be a negative exponent because when you have a negative exponent, it actually flips your fraction upside down. Okay, so when I'm sitting there trying to figure out how do I turn 16 into 1/4, okay, well, if I don't go straight to my calculator, what I'm trying to think is, okay, what value of y is going to give me 1/4? And I think it's going to be -2, but let's see. So 16 to the -2 power. Nope, that didn't work. Oh, not even -1, maybe -1/2. There we go. So in order to get 1/4 over here, I need to have 16 to the -1/2 power. Okay, so I know that y equals -1/2 power. So over here, the answer would be -1/2. So if you're dealing with a logarithmic function that equals a fraction, then most likely you're going to need a negative exponent in order to help you out. Okay. Now in 21 through 27 says use a calculator to evaluate the expression. So basically all they're asking you to do is to plug it in the calculator. I don't even know if we need to do that. So for example, number 25 says the natural log of 0.746. So we just have to basically go in a calculator and you write the natural log of 6.213. And then you just write down, oops, not that. Then you just write down that value, 1.266. There's also, if you go into Desmos, let me make Desmos a little bigger. If you go into Desmos, here it is. Here's the natural log, here's the common log, base 10, and here's a log that has a different base. So here's the secret. Back when we were doing that homework, and I think it's still up on the screen, you actually can, so this is number 15, you can actually say the log base 16 of 1/4 is -1.5. So Desmos actually will solve it for you. This is the problem that we just did. But I want you to know how, excuse me, how it's solving it. Okay. Now this is not on your homework, but I probably should assign it as your homework, which is numbers 29 through 35. So what I'm going to do is I'm going to actually do the problems in 25 through 29 since I didn't assign them. It's just to make sure that, because this is going to help in later things. So number 29 through 35 says simplify the expressions. These are going to look kind of funny. Okay, so we have the log base 5 of 5x, and I want to simplify this expression. Okay, so let's see here. So what I know, and then this equals some y over here, right? So what I know is that I can rewrite this whole equation. So same exact thing we were doing before. This is my base, 5, right, to my base goes to find my answer and then is raised to the exponent. All right. So what do you notice here? You have 5 to the y equals 5 to the x. I know that x equals y. So the answer to log based 5 of 5x is just y equals x. So this whole thing can be simplified as equals x. So basically, if you take a log base 5 of an exponent base 5, it kind of undoes the whole problem. Okay, so then if I do number 33, I have log base 3 of 81 to the x power, and that equals some y, right? So if I rewrite this, my log goes to the basement, so this is my base, to find the answer, which is 81x times some y. I feel like I'm kind of going off track here. So basically, what I want to figure out is what y will make that work. But I think I might want to explain the next section before I do that. So maybe I did have a reason for actually not assigning those problems. So yeah, so just stick with the 3 through 27. And then on Monday, we'll talk about simplifying the logarithmic equations to make it work. The other thing I did want to show while we were here is what does the graph of an exponential and a logarithmic equation look like? So this is the last little part here. So if I have an exponential equation, remember an exponential equation would be like 4 to the x power. Okay, so this is our exponential growth equation, and that's what it looked like. So if I have a logarithmic equation, so if I have the log, oops, I need to do this. Nope, that's not what I want to do. Ah. All right, here we go. So if I have the log, so I have the exponential equation 4 to the x power. This is our growth function, right? It crosses the y-axis at 0, 1, okay? And then you can see if I graph the log base 4 of x, you get this logarithmic function that just looks just like our exponential function, right? Except it's been flipped, and it's been actually flipped about y equals x. So if I put that on there, you can see that the purple graph of the exponential function and the red graph of the logarithmic function are actually inverses of each other. And so that's why one undoes the other one. And so when you graph it, you actually get an exponential graph and you get a logarithmic graph, and they are inverses of each other across y equals x. So I just wanted to show that because it's much easier to show here than me drawing it on the board. That these two have this inverse relationship. Excuse me. All right. So that is all I had for today. If you have any questions, let me know. But Kylie, I appreciate you coming today, and hopefully everyone else is watching online. And I will see you on Monday.